Hi, my name is Ashley Dean, and I'm an Education Extension Specialist with Iowa State University, and I work closely with Erin Hodson, and so we do a lot of the field crop entomology things for the state of Iowa. So today, I am excited to share with you some of the highlights from some of our trapping networks in Iowa. So we'll talk about our moth trapping network, our corn rootworm trapping network that's gone regional, and how those tie into IPM. So kind of an outline of what we'll talk about is why do we trap? So we'll go over some of the basics of why it's important to do trapping. And then we'll talk about the Iowa moth trapping network, the regional corn rootworm trapping network, and I'll share some slides along the way of how you can get involved if you're interested in doing either of these trapping networks with us in 2022. So why do we trap? There are several different reasons that people could choose to trap for different pests. The first one is detection. So that could be the first detection of a brand new species in an area, or it could simply be detecting a species for the first time in a growing season, like we do with migratory moths. Sometimes those trapping methods can also give us an estimate of the population size in the given area. Additionally, sometimes we can get scouting information from those traps, and that's ultimately the goal with these trapping networks, is to provide scouting information for farmers that are doing the trapping, but also in a more area-wide fashion as well. Sometimes we can also make predictions based on the information from the trapping networks or individual traps, as is the case with black cutworm monitoring. And sometimes traps can be used to help make management decisions either within a growing season or for the next growing season, like we do with corn rootworm monitoring on sticky traps. So first, I'll share some highlights of our moth trapping network. So the goal of the Iowa moth trapping network is to monitor 2 migratory moths as they move into Iowa each year. The first one is the true armyworm, and what we'll be monitoring with the trapping network is the adult or the moth. And the adult can be identified because it has a single white spot in the middle of each of its forewings. The larvae are a little more difficult to distinguish from other armyworm larvae because they're all generally striped. They have these striped bodies, but the true armyworm doesn't have a rough appearance like some of the other armyworms do. The other species that we monitor in the Iowa moth trapping network is the black cutworm, which has this dark appearance, and it has one dagger-shaped mark on each forewing. And the larvae are a little difficult to distinguish from other cutworm species, but you can use tubercle size, which are these kind of bumps that look similar to warts on their body. And how you can distinguish them from other cutworm species is the 2 tubercles on the side of the body are different in size as compared to some of the other cutworm species. So what does it mean to be a migratory insect? So I developed this map for a black cutworm presentation that I gave earlier this year, but I think in general it can be applied to other migratory insects as well. So most insects do not like to be cold, and they can't survive the cold, so they can't overwinter in the Midwest. So what they'll do is they'll overwinter in southern states, and then in the spring, when they become active again, they'll move into the northern states on southern storms, usually in the spring, but also throughout the summer. And this can lead to unpredictable infestations. So it would be hard to know when they're going to arrive, but also where they will be and how many will come up on those storms. So that's really why we have the trapping network, is so that we can monitor these things and provide scouting information for farmers in Iowa. So the black cutworm trapping is a long-standing project in Iowa, and I have data from my predecessors back to 2010, so that's over a decade of this trapping effort for black cutworm. And true armyworm was added in 2016. And since about 2018, which is also when I started coordinating this network, we've had about 30 to 40 sites annually. So that's pretty good, and usually we get people from all over the state, and that's what we really want, is to have a lot of sites from all over Iowa so that we can provide the best scouting information for farmers all over the state. So how do we use this information? For true armyworm, it's essentially just detecting when and where the moths are occurring in Iowa. For black cutworm, we can actually make predictions because there is a trapping threshold that says that a significant catch occurs when 8 or more moths are caught over a 2-night period. And this type of a threshold does not exist for true armyworm, which is why we can't make predictions based on true armyworm moth captures. So after a significant catch occurs for black cutworm, which is also termed a biofix, but it basically just means that's when we start, that's the date that we would start accumulating degree days to predict larval activity. So basically when the significant catch occurs, you can expect larvae to be in their 4th instar and large enough to cut corn plants once 300 degree days have accumulated since that date. So basically what I do each spring is I take the information from the trapping network, I determine if significant catches have occurred in different areas of the state, and then I'll use this year's degree day information combined with historical weather information to predict cutting dates. So it's kind of like what could be described as making a sausage. So it's just kind of putting some of these things together to try to make the best predictions for farmers to use as scouting information and help determine when is the best time to begin scouting for this pest. So why do degree days matter? Both insects and plants develop based on accumulating heat units. So sometimes when the life cycle of an insect is closely tied to that of its host plant, it's kind of a race between how fast the insect develops and how fast the plant develops to hopefully be ahead of the insect so that it can withstand any injury from that insect. And this is especially true for something that's migratory and kind of unpredictable. So I just put these two maps up to show you the difference in degree days between 2 different years for the exact same time period. And I used April 15th as a starting date because that's typically about when I get the first record of a significant catch, and May 15th as the end date because that's usually when I'm making these scouting predictions. So as you can see in these maps, in 2012 on the left, much of the state had already reached that 300 degree day benchmark for black cutworm, where they would be large enough to cut corn plants and cause injury in cornfields. Whereas in 2021, so last year, nowhere within Iowa had reached that benchmark yet. So basically, you would just want to be out scouting the fields in mid-May just to make sure that your corn is not being affected by black cutworm, because once corn reaches about V5, they're usually unaffected by black cutworm. So kind of to summarize the moth trapping network, the goal of our network is to detect these migratory moths as they move into Iowa. And then we can use that information to predict black cutworm cutting dates and also provide scouting alerts via ICM News. And so this map here is actually on cornipmpipe.org. You can find black cutworm maps there and also true armyworm maps, but the black cutworm maps are a bit more interesting. Illinois and Wisconsin also have trapping networks that they report on the same website that we use, which is called Ag Pest Monitor. And so all of that data is funneled into corn IPM pipe, where you could go anytime to see if a black cutworm significant flight has occurred. And then once we've predicted cutting dates, that will show up here. So if this were an active map, you could roll over those red counties and it would show you what the predicted cutting dates were for those counties. So basically, more traps are better. If you're interested in the Iowa Moth Trapping Network, feel free to join us next year. And I think at the end, I'll provide some information on how you can get involved if you'd like to. So here are just a few resources you can use to get more moth information. So hopefully you're able to pause this video and write these down or screenshot it or something like that. But you could go to that corn IPM pipe to get moth trapping maps. That may be especially important for people who are in the kind of outlying counties of Iowa where you're near one of those other states that has a trapping network. You can also go to the ICM website to get scouting alerts, summaries, and each spring we will put out our call for cooperators for the moth trapping network. And then kind of hot off the press is this guide to moths in Iowa field crops that we developed just to help people if they wanted to do independent scouting, just to help you get a sense of how you can identify different important crop pest moths from each other. Okay, so we're gonna jump into talking about the corn rootworm trapping network now. So just a little background, I'm sure most Iowans are very familiar with corn rootworm, especially after this past year when populations were huge and generally concerning for everybody. But the western and the northern corn rootworm species are economically important in Iowa and much of the Midwest. So the green one here is the northern corn rootworm, and the yellow one with black stripes is the western corn rootworm. And although they are economically important because they cause injury to roots and they cause yield loss, their importance is increasing as they become resistant to different management tactics that farmers use against them, like Bt hybrids, insecticides, and crop rotation. So in the future, scouting is going to become more critical in identifying any of these issues, as well as just if you have corn rootworm in your field. So we worked with some folks from the Midwest to help form a regional corn rootworm monitoring network. So you can see from this logo graphic here, most of the people who are involved. There are a few people that aren't in this graphic because I haven't had it updated yet. But basically it's 12 US states and 5 Canadian provinces, and it's kind of a mix of university, industry, and government personnel who all wanted to work together to promote scouting and the use of sustainable corn rootworm management tactics. So in the spring of 2021, we all worked together to kind of develop these shared objectives for the regional corn rootworm monitoring network. So we wanted to increase scouting efforts in corn. We wanted to understand changes in populations between years, and kind of on the same note, we wanted to raise awareness about changes in western corn rootworm and northern corn rootworm activity. So this could be something like what happened this year, where we just had a lot of rootworm beetles and people were generally worried about rootworms even if they hadn't had issues in the past. But also it could be if the ratio of these species is changing either in a particular field or across a region. That's something we would want to be able to monitor and assess. And then, of course, the final objective is to help promote the use of appropriate management strategies based on the scouting information from these fields. So we provided free sticky traps to volunteer cooperators in exchange for some information about the field. So our volunteer cooperators could be farmers, but they could also be agronomists or crop consultants who wanted to scout the field for the farmer. So we asked for location information. So if people could give us GPS coordinates, that was excellent, but sometimes people weren't comfortable sharing that. So they would give us the nearest town or county level data or something like that. We also asked for some field history. So about the crop, we would want to know what crop are they putting the traps in, what was the previous crop in the field, and if they had this information, we wanted to know how many years of corn on corn had that field been. And then if they knew what hybrids were planted this year, but also in the past, that would be valuable information. And then we also wanted to know some things about corn rootworm. Do they have issues either now or have they had issues in the past in that particular field? And do they suspect resistance to any of the management tactics in that field? And then we just asked people to report their data weekly for each trap individually, either via email or by using Survey 123, which I'll talk about a little bit later. So what we asked people to do was just to put out a single transect of 4 traps, and these traps would be placed about 50 meters into the field, so away from a field edge, and then every 50 meters along a single row. And we asked people to trap for just 4 weeks, starting around mid-July. So the start date would vary quite a bit based on the location, because we had a wide range of geography involved in this trapping network. So we aimed for about mid-July, but we told cooperators to do what was best for them because we wanted to capture the peak emergence period of corn rootworm. So corn rootworm emerge for a period of 6 to 8 weeks, and obviously if we're trapping for 4 weeks, we're not going to capture the whole thing, but we're hoping to capture the peak. So what we wanted farmers and agronomists to do is to try to time placing those traps out such that you would get that peak emergence. So usually around silking, or if you're out looking for beetles, we would suggest a week or 2 after you found the first beetle is when you would place those traps. So this protocol is a bit modified from the official trapping protocol because obviously if you have more traps in the field, you could get better resolution to make management decisions from those traps. So typically you would have 2 transects and 6 or 8 traps in each transect, but we also understand that that is a huge effort for people to do, and so we wanted to make this as simple as possible and something that farmers would be excited to participate in. So I mentioned Survey 123 earlier, so we used it. This was the first year that we used Survey 123, and it's a data entry system that people can use on the go because it's either a desktop or a mobile application. So most of the people who participated were using the mobile application, so they could just enter the data as they were checking the traps in the field, and then it would just upload as soon as they had either cell signal or Wi-Fi. And so I think this was really a great way to get people to enter that data in a timely fashion as well. And we thank Dan Bahari and Tracy Bowdy from Ontario for helping us get that all set up. We couldn't have done it without them, especially as quickly as we needed to get that up and running. So, okay, so the next few slides are just going to be a summary of the regional trapping network. So I won't be sharing Iowa-specific data today. It'll be more general to the entire regional trapping network. So we had 619 unique locations that were entered into Survey 123, although I know that there were many more that were not entered either due to privacy reasons or because people just didn't get them entered fast enough, and I needed to use this data for some presentations. But it comprised 14 U.S. states and 5 Canadian provinces. So you'll notice that 14 is more than the 12 that I told you that we had earlier, and that's because some people from Colorado and Texas found out about us using Survey 123, and they wanted to contribute, even though they weren't established as part of our regional network. So you can tell that Iowa has a lot of traps. We had the most traps of any area involved in this network. And that's mostly because we had some folks from Syngenta who were also putting data into this Survey 123, and they already had an exceptional in-house trapping network. And so they put all of their data into Survey 123, and that's why we had so many sites this year. But we got some good data from this network. So first, I just wanted to look at what crop did people place their traps in. So of course, for the most part, because we're monitoring corn rootworm, people were putting their traps into cornfields. So that was the most prominent trap site crop. But people also placed them in soybean. And you can tell by the map that that was basically, the majority of those were in Illinois and Indiana. And that's kind of the epicenter of where you would find the Western corn rootworm variant that has that behavioral adaptation to crop rotation, where the females lay their eggs into soybean fields. And so a lot of the trapping efforts in those two states have been centered on trapping in soybean. So that's why most of those are in that area. Next, I wanted to look at the crop rotations that were used throughout the network, because continuous corn is the biggest driver for having rootworm issues in the field, but also for the development of Bt resistance. So most of the sites where corn rootworm was trapped this year were using a corn-on-corn rotation. And then some were in a corn-soybean rotation, and very few were in some other rotation. So maybe it was pasture the year before, or perhaps it was alfalfa, or maybe they didn't get to plant it for some reason. But it was some other crop rotation besides corn-on-corn and corn and soybean. And then I was interested in looking at what corn rootworm issues were being reported through this network. So you can tell that these numbers don't add up to 619, and that's because either people were not reporting that they had issues, or they didn't want to answer the question for some reason. So, but most of the people who reported having issues said that the issues that they were experiencing was high beetle populations, or goosenecking or lodging, which occurs from when the larvae are feeding on the roots and the root systems are weak and the plants fall over, or some combination of those two. So goosenecking and lodging, and plus high beetle populations. There were 7 sites that reported having 3 or more issues, but very few people reported that they suspected resistance to either Bt or crop rotation in their field. Another thing that I wanted to look at is what corn rootworm management tactics were being used in these fields. So we specifically asked people about Bt rootworm hybrids, high-rate seed treatments, a soil-applied insecticide for larval control, and a foliar-applied insecticide for adults. So you can tell here that the Bt rootworm hybrid alone is the thing that was the most reported management tactics. So there were 40 sites that reported using the Bt rootworm hybrid alone by itself. What was interesting to us was that about half of the sites, 49 sites, that actually answered the question, reported that they were using more than one management tactic for corn rootworm, and 13 of those sites said that they were using 3 or more tactics to manage corn rootworm in the field. And this was interesting to us just because it's not something that we would recommend. We wouldn't recommend that people use more than one management tactic for corn rootworm. And that is because research has shown that there hasn't been any yield benefit and it also hasn't reduced larval injury to corn, so it hasn't reduced the node injury score if people were to use a BT plus a soil-applied insecticide. And also, it hasn't led to a reduction in the number of adults that are produced, and there can be resistance management implications for layering management tactics. So it's just not something that we typically recommend, and it's good information to know that about half the sites in our network were using more than one of those management tactics. There were 16 sites that said that they were not using any management tactic for corn rootworm. Another thing that I wanted to look at and kind of map is which species was reported as being the most dominant species. And so the way that I did this is during the peak week at each site, so the week where most of the corn rootworm beetles, the total corn rootworm beetles were reported, which species represented more than 50% of the beetles. And so the blue dots on this map mean that at those sites during the peak week, northern corn rootworm was the dominant species. The orange dots are western corn rootworm. And then if neither were the dominant species, so either they were equal or there weren't any beetles reported in those fields, those are a gray dot on this map. So because I think this is kind of hard to see, I wanted to break these out. So this map just shows all of the sites where northern corn rootworm was the dominant species, and this map shows where western corn rootworm was the dominant species during the peak week at each site. So it's important to keep in mind that the peak week is not the same for each of these sites. And it's also important to know that there's some differences in the timing of the peak for each of these species. So that's something that we'll want to investigate a bit further, but for the purpose of this presentation, I thought it was interesting just to see where each species was reported as being dominant. Okay, so what I think most people are interested in is the beetle counts at each of these sites. And so this is represented as corn rootworm per trap per day during the peak week at each site. And the reason that we use this metric is because there is a trapping threshold that exists that says if 2 or more beetles per trap per day are captured in the field, that's when we would want to do something different the following year for management. So basically just we would want to manage with confusion if you're catching that many beetles in the field over, usually it's a week. And so in this map, the gray dots are where there were no beetles trapped, and then the green dots are indicating that 0 to 2 beetles were captured. So most of these sites are under that trapping threshold. The yellow, orange, and red sites, with red being the most beetles per trap per day, are all sites where the corn rootworm per trap per day during the peak week exceeded that threshold of 2 beetles per trap per day. So just to see that a bit more clearly, we can take away those green dots, and this map here is showing all of those sites that exceeded the trapping threshold. And so I think this accounts for about 29% of the sites were over that 2 beetle per trap per day threshold. So that's really interesting to us. We're not sure exactly what that would mean, especially considering the exceptional year that we had for corn rootworm, where there were just a lot of beetles, and even people who hadn't had beetle issues or corn rootworm issues in the past saw beetles in their field. So just something to keep in mind as we look at these maps. To better illustrate the protocol for setting up corn rootworm sticky traps in the field, We recorded this short video to kind of show you how to set up a trap and then explain how you can use that information to make management decisions in your field if you would like to. So here's that video. Hi, my name is Ashley Dean and I am an extension entomologist for Iowa State University. And today I wanted to show our cooperators for the Iowa Corn Rootworm Monitoring Network how to set up a yellow sticky trap for monitoring corn rootworm adults. So first I would like to thank our cooperators for helping us with this project this year. It's our first year trying to coordinate this networking effort. So since I imagine most of our cooperators may not have ever set one of these up, I just wanted to make sure that you knew how to. First of all, we are using these Ferricon non-baited sticky cards for corn rootworm monitoring. And some important components up front is these 3 circles here that you can punch out to use this twist tie in order to secure the trap to the plant. And then this little tab down here at the bottom, you can punch it out, put this tab in this hole to secure the bottom part to the plant. So first, what you'll do is you'll take the sticky card, and it's really sticky on the inside, and you'll just pry it apart and then flip it and kind of fold it so that the sticky part is on the outside. And then what you'll do is you'll want to take the leaf that is right above the ear, and you'll want to either bend it or completely take it off the plant so that it's not in the way when you put the trap on the plant. And then you'll settle the trap right above the ear, twist it around the stalk, and then you'll secure this little tab at the bottom. And then I like to put this twist tie at the top so that you have another secure point on the plant so that the trap doesn't fall off. And then you'll just twist the twist tie, and then your trap is ready to go. When you come to the trap, you will basically do the reverse of when you assembled it. So you'll take the whole trap down. You could count the beetles on the trap in the field, but I highly recommend, since you'll be further in the field than I am today, taking the trap down. So I'll demonstrate that process. You could take your twist tie off and then pop the little tab out. And then what I would do, since there will be insects completely stuck to this, I would gently close it, and you want to be careful not to smush the beetles because you'll need to identify them later. And then you could secure the tab if you wanted to, but whatever is easiest for you. And then once this trap is taken down, you'll replace it with a new fresh trap. Okay, when you establish a transect in a field, we recommend placing a flag or some sort of a marker at the edge of the field so that you can find the transect later. What you would do is you would walk about 165 feet into the field interior and place your first trap. And then every subsequent trap should be placed along the same row every 165 feet. So for our trapping network, we're only using 4 traps, but usually a transect would have maybe 6 traps. And then if you wanted to establish a second transect in the field, you would need to make sure that they were approximately 330 feet apart from each other. After you've left your sticky traps out in the field for 1 week, you would come back and collect the traps and take count of any of the corn rootworm beetles that are on the trap. So mostly you're just looking for western corn rootworm and northern corn rootworm. And sometimes it's a little bit difficult to see right away what species these are because a lot of times, well, they're stuck to the sticky trap, but also they'll flip themselves over, and so you won't be able to see the markings on their elytra, which is how you would identify these species. So I often recommend taking these traps out of the field so that you can flip those beetles over and correctly identify them. If you get more than 2 beetles per trap per day, so that's an average of all of the traps that you have in your field, you would maybe want to consider doing something different next year. So, for example, if you're growing continuous corn in your field, you may want to consider soybeans the next year, because that would help break up the life cycle of the corn rootworms in your field. And then if you're using maybe a Bt trait in the field, you may want to consider a soil-applied insecticide as management for the following year. Just some final thoughts on our corn rootworm trapping network. First of all, we will be continuing this in 2022, so if you're interested in getting involved, I'll share my contact information at the end. Corn rootworm populations are highly dependent on in-field management practices, so it's important to keep in mind that we can't extrapolate the data from an individual site to a county level or a region level, because it is highly specific to what is happening in an individual field. But what we hope that we can do with this network is to document changes over time. So it could be documenting changes in total beetle populations or the ratio of westerns and northerns in a particular field. And the latter is kind of what's really important to us and kind of sparked some interest in this effort, is because we have been hearing a lot of people say that they have been seeing more northern corn rootworm in their field, and we're not sure if maybe there's a shift in which species is more dominant in these fields, or maybe it's the first time that people are out and noticing them in such high numbers. So it's something that we just want to keep an eye on and document over time. We also want to use this network to encourage scouting, especially with something like yellow sticky cards, which is what was used in the rootworm trapping network, which is a relatively easy scouting method for farmers to use or their advisors to use to estimate populations and try to make management decisions with that information. And then finally, we would like to use the scouting information from this network to target future extension efforts based on these results. So I just wanted to highlight briefly this new website that we created for this year. So it's called the Corn Rootworm IPM website, and I think I'll share a link in one of the following slides. It's new this year, and it is kind of a collaborative effort with the entire regional trapping network. And so basically we wanted to have a centralized website where we can have all the information that someone might need about corn rootworm, the contacts, the area contacts that people could get in touch with in different regions to either get involved with the trapping network or ask questions about corn rootworm if you have them. There are also links to the regional network on this site, and we hope to keep it updated with news and events related to corn rootworm as they come around. So here's another resource slide. So if you can pause the video, write these down, or take a screenshot or something like that, this is where you can go to get more rootworm information. So here's the link to that Corn Rootworm IPM website that is new this year. You can also get to the Adult Trapping Network on that website, so I've included that link here. So it'll take you to Survey 123, where there is an instructions page where you can learn how to get started on Survey 123 to enter your trapping information if you're planning to put up traps yourself. And then, of course, the ICM website again, which is where we will post summaries, any rootworm news, or our call for cooperators, which usually comes out in May. So the way you can get involved is either to email me or bugtraps@iastate.edu to just let me know that you're involved in one or both of these networks. Or you could subscribe to the ICM blog, which is where I will post our call for cooperators. So you get a call for cooperators for the moth trapping network in February and one for the rootworm trapping network in May. here on this slide is also Erin Hodson's contact information if you'd like to contact her for anything rootworm or moth related. And that is the end of my presentation today. I'm really excited to be able to share with you this information about our trapping networks, and I'm excited for 2022 Trapping Network, and I hope to see some of you guys get involved and help us trap for these pests. Thank you.